source project for Intro to SWE class. So starting off with the basic idea of the project that I decided to contribute towards, it is called SuperDuper, which is a Python-based framework for building end-to-end data workflows and application. It integrates seamlessly with major databases, supports all of like the classic cutting-edge technologies like LLMs, vector search, and also all the other AI ML paradigms. So it's essentially a tool for developers. The benefits you get is that you avoid the need to implement ML ops, ETL pipelines, model deployment, etc. So what it does is that it lets developers build compositional and declarative objects that can handle like all these processes, deployment, versioning, orchestration as well automatically. So the way it looks like the basic workflow is that you connect to your data, then you apply your AI model or ML model, and then you package that application for reuse, and then you can execute these AI-powered queries as well. So the core features here is that first, you can create data layers using your own database, and then you complete your implementations. Then the topic that I just mentioned about like being able to reuse certain part of your code. So there's something called components, which lets you reuse units of your functionalities. You can start it, store it, and then you can collaborate on it. And then there's something called Super Duper Protocol, which is just their way of being able to provide web-friendly serialization for tracking all of your experimentations, versioning, etc. And then there's also like AI database queries, a feature where you can create queries on both your AI outputs, both like your primary database data and also like AI generated outputs as well. So the key benefits here is that obviously you get that flexibility of being able to like combine your Python-based AI model with leading databases, but also that factor about like being able to create those reusability functions where you can package components as templates and then reuse them. So there's also like you can implement a vector search, which is good for like cost saving. And then also it's very easy to deploy workflows with one click. I have worked with some like ML models in past, so this was like very interesting and to me, and that's why I wanted to work on this. So the issue I picked is merging SQL vector and vector data types. So the basic idea here looks like that there are two data types, and this kind of was creating a lot of like slowdown. So being able to implement something that can be used for like both of them. So a data type basically. So here I'm just gonna give like a quick overview of the GitHub repository. Here you have like the licenses and like the README, make files and all of that. And then you have like the SuperDuper templates and test files. SuperDuper is the main directory. Here you have your backend files, base files, components. That's the main feature. And this is where and then you have like an LLM folders as well. This is where I'm gonna be implementing my code. So jumping to data types right here. So here, the essential idea of this entire file is that you're able to first start with like creating abstract classes for data types. You have the meta class, you have the base class for that data type, and then you have base vector, which is the base class for your vector. So I'm going to be using this as a parent class, and building upon that is my unified vector class. So as you can see right here, it's a unified class for encoding vectors for both general use and SQL backends. And then I implemented a data type IMPL function here, which is able to fetch the appropriate data type and implement the appropriate encoding and decoding functions. And then we have the general vector and the SQL vector, which are just like the helper classes. So both encoding and decoding as bytes for general use and for SQL-based backends. And then there's like a unit test file right here. So I don't have enough time to implement it on like a complete data set. So I just created like an NumPy arrays to show you the functionalities right here. So as you can see, it passed my test cases. And yeah, that was the basic idea of my project, creating a unified class. I implemented the unit test cases as well.